everyone, and welcome to Algebra. Today we are doing section 6.3 on logarithms and logarithmic functions. So to explain where logarithms come from, think about this equation. If I asked you what 2 to the x is equal to 8, what is x? Hopefully you would say x is equal to 3. Or what if I said 5 to the x is equal to 25? You might say, hopefully, x is equal to 2. But what if I said 5 to the x is equal to 26? Now, see, that's not going to be a perfect number. We know 5 squared is 25. 5 to the third is all the way up to 125. So you might guess and say, well, it's got to be pretty close to 2, maybe 2.1, but you wouldn't really know for sure. Logarithms are a way of solving these equations. Logarithms are just a way of rewriting this backwards and giving it its own notation. So, this is the rule that you need to know to convert from an exponential form to a logarithmic form. This is going to be pronounced log base b of y is equal to x. This is pronounced b to the x is equal to y. But we still know that this is the base and this is the base. So they match each other. But like all inverse functions, square roots and squares, they reverse the x and the y position. So if I say y is equal to the square root of x, then y squared is equal to x. Well, in this case, I have the log base b of y, but in exponential form, I have base b to the x. I think it might be easier just to show you with some examples. So log base 2 of 16 is equal to 4. That's the base. And so now if I change it to exponential form, 2 is the base, but now these two switch locations. So 2 to the 4th is equal to 16. 4 is the base. So 4 is the base of my exponential notation, and these switch locations. So now the 4, instead of going with the 1, is going to go with the 0. And sure enough, 4 to the 0 power is 1. 1/4 is my base to the -1. That becomes the exponent is equal to 4. So these expressions are equivalent. This is logarithmic notation, and this is exponential notation. And they have different uses. Now let's do it the other way. Now let's take each of these exponential problems and write them in logarithmic form. So I write log base 5, which you should lower. It's a subscript, of 25 is equal to 5. On this one, log, the subscript is going to be base 10 of 0.1 is equal to -1. Now my base is base 8. That's the base of the exponent, but it becomes the base of my logarithm. Log base 8 of 4 is equal to 2/3. And the last one, log base 6 of 1/216 is equal to -3. So I realize that it's a completely new and unusual way of writing things, but it does have a lot of value. So log base 4 of 64 is probably not something you'll ever become comfortable with, even though you do with other things like square roots and squares you're probably equally comfortable with. Probably not exponents and logs. So we're going to convert it. They're saying evaluate this. What is this equal to? Let's convert it to exponential form that you are more comfortable with. Base 4 to the x is equal to 64. And hopefully you're saying, oh, yeah, now I can see what it is. X is 3. On this one, it's saying to evaluate this. What is this equal to? Well, it's just saying 5 to the what is equal to 0.2. And you might be saying, well, now I don't know. Well, let's think about that. This is a base 5, and 0.2 is the same as 2/10. which is the same as 1 over 5, which is the same as 5 to the first on the bottom, which means it's the same as 5 to the negative 1 on the top. Now, do you see it? Took a little work, but log base 5 of 0.2 is negative 1. You could try and do these next two on your own, but in case you can't, I will do them for you. So I'm trying to evaluate this. It's easier if you put an x there. 36 to the x is equal to 6. So you might be thinking, I don't know how to do that. Well, you could change this one to 6 squared to the x is equal to 6. Now they have the same base. And do you remember how to combine these? Addition or multiplication? Hopefully you said multiplication. And this is to the 1. So I can write 2x must be equal to 1, so x is equal to 1/2. So log base 36 of 6 is equal to 1/2. And last one. 1/5 is the base. To the x is equal to 125. I can rewrite this one as 5 to the negative 1. And I can rewrite this side as 5 to the third. So that gives me 5 to the negative x is equal to 5 to the third. So negative x must be equal to 3, which means x must be negative 3. So log base 1/5 of 125 is negative 3. Now you'll notice that back here I did have one that was log base 10. Base 10 is actually called the common log. So that was decided to be the one that you do not have to write the base. If you see log of something and there's no base, no, it's just that it's base 10. And you guys are familiar with this concept of omitting something. When you see 3x squared plus x plus 8, you know that there's a 1 there, you just can't see it. Same thing here, you know there's a 10 there, even though you can't see it. So nobody writes log base 10 of x. Instead, they just write log of x. And nobody writes log base e of x. They just write ln of x. So this is pronounced ln of x. That's how you pronounce that, although it's written in lowercase letters. It's a little bit confusing why they would do that. It was named by somebody in France. So instead of natural log, which would be NL of x, it got to be, think of it as log natural. So that's why it's ln of x. All right, so you can get out your calculators to do these logarithms. So your calculator does have a log button. It's right here next to the 7. So to do log 8, you literally log 8. Close your parentheses, which is above the 9, and hit enter. For natural log, that button is right next to the 4. So you can just use natural log, 0.3, and you can get that answer. Now, if you have a log of any different kind of base, you're going to want to go to Math, and then you can't see it on this list, so it's way down there. It's after 9, 0, there it is at A. And look at that, it makes that perfect little logarithm notation for you. You can fill that in and get your answer that way. Last one, Math. Now as a little shortcut, instead of scrolling all the way down, you can go up, and then it's only 2 away, just as a little shortcut there. And log base 7 of 29. I'm not actually going to hit enter. I've shown you 3 just to show me that you did 1 on your own. Go ahead and fill that in on your notes. Because exponential functions and logarithmic functions are inverses of each other, they undo each other. So think about it like this. If you have multiplication, the inverse operation is division. So if you divide by 3, you're left with just x. The inverse operation of addition is subtraction. So if I subtract 3, I'm left with just x. The inverse operation of a square root is a square. So if I square it, I'm left with just x. Well, similarly, if I have a log base b, which is a logarithmic form, but then I have an exponent of b to the x, I'm right back to x. And conversely, if I have an exponential form with b to the something, but that something is a log with base b, it also goes right back to x. A little harder than squares and square roots and cubes and cube roots, but you definitely are going to want to get the hang of this. This will help you simplify a lot of problems in your next several years of math. So this one, you can't really see that base. Do you remember, if you can't see it, that it's a 10? So I have an exponent with a base 10 to the log with a base 10. That cancels each other out, and I just get 4. This one is log base 5, but this base is 25, so they do not cancel each other out. But if you rewrite it, this is log base 5. If I can rewrite this as a base 5, they will cancel. So I can do that by changing the 25 to 5 squared. Then I have log base 5 of 5 to the, I put a 4 there. It's actually an x. 5 to the 2x. Remember, you multiply when you're doing a power to a power. And so now a log base 5, but then an exponent with a base 5 cancels each other out. On this one, I have an exponential function. So it might just be easier for me to rewrite it big. So this is the base of an exponent, just like 8 to the third. But if that exponent is a logarithm, and the base of that logarithm is the same as the base of the exponent that I'm doing, then they cancel each other out, and I just get x. Now, I will say that sometimes kids try and write the x up in the air. I don't know where it's supposed to be, but just somewhere up there. It's not. If you had a piece of paper with lines on it, it would be back down on plane. So it undoes it, and it's just x. I have a log base 7, but then I have log base 7 of an exponential function of base 7. So they cancel each other out, and I just get 3. You can try that next one on your own, but of course I will do it for you. Log base 2 and the 64 aren't the same, so they don't cancel. But if you could make that 64 into a 2, then it would work. And sure enough, it's 2 to the 6. So again, take this extra step here. This is 2 to the, is it 6 plus x or 6x? It's 6x. You multiply exponents when you have a power to a power. And then now this log base 2 of an exponent with base 2 cancels each other out, and you just get 6x. So remember what an inverse function is. To find an inverse, step 1 is change f of x to y. Step 2, reverse x and y. And step 3 is to solve for y. So in its simplest terms, if you had f of x is equal to x squared plus 1, then your first step would be change that to y is equal to x squared plus 1. And then you would reverse x and y. X is equal to y squared plus 1. And then you would solve for y. So I would subtract 1, and then I would do the square root. This is not actually an inverse function because it's both the positive square root and the negative square root, which doesn't pass the vertical line test. But that is the inverse. Those are the steps. So we're going to do those same steps. This is y is equal to 6 to the x. I'm going to reverse x and y. So now I have x is equal to 6 to the y. And then step 3, I'm going to solve for y. Oh my goodness, how do I solve for y? How do you get that y alone? In this case, you're going to do that by changing to logarithmic form. Obviously, I put it in a different color. That's not for all inverses, just for inverses involving logarithms. So step 3 is, you may remember from the very beginning of this lesson that I can switch this. 6 is now going to become the base, not of the exponent, but of the logarithm, and then the x and the y trade places. That is the inverse function. Technically, there's a step 4. If you want to go the extra mile, that would be great, and actually call it f inverse is equal to log base 6 of x instead of just y. So step 4, rewrite y as f inverse. Okay, so the next one. First step, change f of x to y. Second step, reverse the x and the y. So now I have x is equal to log base 5 of y. Third step, solve for y. So I don't know how to solve for y, but I can change to logarithmic form, or if it's already in logarithmic form, now we're going to change to exponential form. And that's how you can solve for y. So if it's log base 5, then it's going to be an exponent with a base 5, but now it's going to be 5 to the x is equal to y. And like I said, if you wanted to have a really nice step 4, f inverse is equal to 5 to the x. Now, I will say that students really struggle with this particular topic, the inverse. I think it's because they get this step, step 1, changing the f of x to y, and then they get this step, reverse the x and the y. But when they go to do step 3 also, in a sense, involves reversing x and y, because you're changing it from logarithmic form to exponential or vice versa, and you're moving the x and the y to opposite spots. And it feels like you're undoing what you just did. So I'll tell you another way to think about it, and that is, in much more general terms, if you have 4 to the x, remember, inverses and logarithms are inverse functions, then the inverse function is log base 4 of x. Just that simple. You can avoid all these steps just by saying, well, if you have 4 to the x, then the inverse is log base 4 of x. It is a little bit trickier with natural log, but if you think of this as log base e, remember, nobody ever says this. This way of writing it, natural log of x, is how people write it. But in your head, you should be thinking that's base e. So the inverse of the natural log of x is just e to the x. Let's go back and do the first two that way. So what's the inverse of 6 to the x? The inverse is log base 6 of x. And look, that's what we got. What's the inverse of log base 5 of x? The inverse is 5 to the x, which is what we got doing the normal steps. But if you want, you can just think to yourself, logs, exponential functions, inverses. So the last thing that we're going to do is we're going to graph logarithmic functions. I cannot stress enough this step. You will never learn how to graph a straight up logarithmic function. Instead, you're always going to convert it to exponential form. That's the key. You convert it to an exponent, it's going to be a piece of cake. So, I can write it again. Exponential form. It's that important. I'm writing it twice. So if somebody asks you to graph y is equal to log base 3 of x, don't do it. Just change the form. You're not finding the inverse this time. We've moved on. Now you're changing the form. So 3 to the y is equal to x. These two mean the exact same thing. I've just changed the form. And now make a table. The only difference is you don't want to plug numbers in for x. That would be hard. Instead, pick numbers for y. pick numbers for y. So when y is 0, anything to the 0 power is 1. When y is 1, 3 to the 1 is 3. When y is 2, 3 to the 2 is 9. So 1, 0, 3, 1, 9, 2. Any idea what the rest of the graph is going to look like? Think about inverses. So with an exponential function, exponential functions look like this. But logarithm functions are going to reflect over the line y is equal to x. That's what all inverse functions do. So logarithmic functions are going to look like this. So its asymptote is going to be right here. It switched, it flipped. That's what inverses do. It used to be for the exponential function, it was on the x-axis. Now it's going to be on the y-axis. So we're going to come up right along that y-axis there and then follow through our points. Our domain is going to be x is greater than 0. You cannot take the log of a negative number. The range is going to be all reals. The x-intercept, even though I kind of missed it there, is going to be 1, 0. The y-intercept is not going to exist because I don't go through the y-axis unless we shift it left, right, which we're not going to do right now. And then the asymptote is going to be the vertical line, x is equal to 0. And if you look back at your exponential notes, you'll see every one of these is backwards from what it was before because they're inverses, and inverses flip everything to do with x and everything to do with y. All right, on the next one, y is equal to log base 5 of x. So it doesn't say y. In your head, f of x and y should mean the same thing. Don't do that. Change it to exponential form first. So 5 to the y is equal to x. Notice it is not an inverse. These are inverses. This is separate. I want to graph this function, and this function is 5 to the y is equal to x. So I make a quick table, and I plug numbers in for y. Remember, pick for y. So anything to the 0 power is 1, 5 to the 1 is 5, and by 2, it's already too big. So like with exponential functions, there's not going to be that many points to graph, which means the key is knowing your shape and your asymptotes. If you know your asymptote and you know the shape, these will not be hard to graph because there's only a couple points to plot. Notice I only wrote this once in the center of the page. That's because it's the same for all of them. Every single one of them is going to be the same until we start shifting it left, right, up, and down. Okay, f of x is equal to log base 1/3. So now, again, this is y. So 1/3 to the y is equal to x. Actually, I'm just going to go ahead and draw this before I even start. Right? Those are the two things I always know. It's asymptote, as long as I haven't shifted it, and it's asymptote and its x-intercept are always going to stay the same. I go to make my table, and I pick a number for y. 0 is easy. Anything to 0 power is 1. I already have that point. When I go to pick 1, I have 1/3. So when x is 1/3, I'm up at 1. All right, well, let's pick 2. Ooh, that didn't get any better, did it? 1/9. So at 1/9, I'm at 2. Do you think you know what's happening yet? Yeah, we're going to have to pick a negative number. This happened when we were doing exponential functions too. Do you remember that when we had y is equal to 1/2 to the x, we talked about how those went down, and so it was easier to pick negative numbers for x because then you got nice numbers for y. When you picked positive numbers for x, you got these little fractional numbers that were hard to plot. So it's the same concept. If you see that there's a fraction here, you're going to want to plot some negative numbers. So 1/3 to the -1 comes out to be 3. 1/3 to the -1 is 1 to the negative 1 over 3 to the negative 1, which is that moves to the top and that moves to the bottom. And so it's just equal to 3. So when x is 3, y is negative 1. Let's do one more. Negative 2 is going to flip this one, so positive 9. 9, negative 2. So if you have a fractional base, that's going to be the shape. It's going to go down. But in general, the general format, the general thing that you're going to see, the graph, the shape of the graph is going to be this shape right here for most logarithms. This one's only for a fractional base. So going back to a regular one then, I have y is equal to log base 4 of x. That is equivalent to the exponential form, 4 to the y is equal to x. Before I even make my table, I can go ahead and draw my asymptote in this one point. It's going to go through. I pick numbers for y, and I pick 0. 4 to the 0 is 1. Already have that point. When y is 1, 4 to the 1 is 4. When y is 2, I'm already at 16, which is too high. So there's not a lot of points to plot. It's all about knowing the asymptote and the general shape. Notice I stayed below. When I was out here at 10, I'm still below the y value 2 because I won't reach 2 until I'm all the way out at 16. So be careful that you're not too hasty when you draw these. All right, we are just going to briefly touch on translation, although this will be the heart of the next lesson. But I want to say it today and next class, which is graph the parent graph first and then shift. In other words, I cannot stress this enough. Start with y is equal to log base 2 of x. Just don't even try and shift it, okay? You need to start with this graph first. So my first step is to change it to 2 to the y is equal to x. So that hasn't changed. Changed to exponential form. I go to make my table, and anything to the 0 power is 1. 2 to the 1 is 2. 2 squared is 4. I can actually fit another one in there probably on my graph. So I've got plenty of points. And now that I have these points, I can shift. But do not try and incorporate the minus 3 into this equation somehow. All right, so I'm going to shift. You guys are going to love this. It's just the same as always. Because it's inside the parentheses, you're going to go to the right 3. So here's my new origin. New origin. And that means that this should be on there. And then this point. And that's my 1, 0. So I'm pretending this is my origin. There's 1, 0. Here's 2, 1. If I started there, 2 and then 1. Then 1, 2, 3, 4, and then 2. And it turns out I can't do 8, 3 because I shifted. If I had shifted to the left, I would have been able to fit it. And there you go. So again, I would ignore the plus 2 at first. Ignore to make your table. It will be so much easier. So this is y is equal to log base 3 of x. And I'm going to rewrite that. That is equivalent. It's the same exact thing to write 3 to the y is equal to x. But this is going to be something we can graph. So I pick numbers for y. Anything to the 0 power is 1. 3 to the 1 is 3. 3 squared is 9. And now I'm going to shift. So my new origin is going to be up 2. Up 2 to make new origin. So that's my origin, which means this is going to be my line asymptote. So notice that it didn't move because I just went up. It's only the asymptote's only going to move when you move left or right. And then from there, because this is my origin, I'm expecting to do that point right there. And sure enough, 1, 0 is there. and then also 1, 2, 3, 1, and then also 9, and then 2. And that's how you're going to do that. Or at least that's how I do it, and it works really well for me. All right, the rest is extra practice, so we are done with section 6.3. Have a great day.